I hope. So let me see here. This is similar to what we talked about yesterday. I'm standing on a ladder. I'm a 100-foot ladder this time. All right, I'm leaning against the house. So this is 100 feet right here. That's not changing, which is why we label it a constant. And let me see here, the ladder at the bottom begins to slide away from the house. So that's down here. This is changing. And they're telling me that dx dt, which I'll write up here, I guess, is 10 feet per second. So if x is growing, y has to be shrinking, and y is right here. So I must be falling down. And that's the question. How fast am I falling when the ladder is 60 feet from the house? So we're going to do Pythagorean theorem again for this. And the Pythagorean theorem to set this up is going to be x squared plus y squared has to be 100 squared. Cool. Which is what, 10,000? So when we derive this, because we have to derive it because we want to know dx dt, or we want to know dy dt is the question, which we'll write over here. When you derive it, you get 2x dx dt plus 2y dy dt equals, and when you derive 100 squared, please don't do the power rule. 100 squared is just a number. It's 10,000, so when you derive it, you just get 0. Cool. We're looking for dy dt, so that's going to be in our equation still. We don't know y yet, but we can find it. Because if x is 60, which is what they told us in the problem right here, and y is 100, I'm sorry, then the hypotenuse is 100, then y has to be 80. That's a 3, 4, 5 triangle. So this works out a little bit nicer than the last one in terms of the numbers we get. dx dt was 10, and x was 60. So that's the whole problem. We just got to solve for dy dt. And when you do that, you get negative, what, 20, 60, 12. Is this 1200 though? Over 160. And the zeros cancel, so 120 over 16. And what goes into that? Oh, 8. Good call. Negative 15 halves. And that's going to be in feet per second. Cool. And it should make sense it's negative because y is getting smaller.